What's up, guys? It's Mr. Brengle, and today we're going to continue working on our acceleration math practice problems. We've previously done numbers 1 and 2. We're going to do 3 and 4 today. So going into number 3 here, it states that while driving his sports car at 20 meters per second down a 4-lane highway, Eddie comes up behind a slow-moving dump truck and decides to pass it in the left-hand lane. If Eddie can accelerate at 5 meters per second squared, how long will it take for him to reach a speed of 30 meters per second? And then how long will it take would be what we're going to solve for here. So when looking at this, I see, oh shoot, I've got two velocities here, two speeds. I've got 20 meters per second, I've got 30 meters per second. One of them's the initial, one of them's the final. He's driving a sports car at 20 meters per second. He then accelerates to pass it and does that by reaching a final speed of 30 meters per second. So initial is 20 meters per second. Final velocity is going to be 30 meters per second. The acceleration it gave us was 5 meters per second squared. And then it's wanting to know how long is this going to take. So we go to our acceleration equation flowchart and we ask the first question. Did this problem give us a number for or ask us to solve for change in position? Meaning delta x in this case because it's a car moving left or right, or if it was up and down, delta y. The answer is no. It did not ask us to solve for it, didn't give us a number for it. We didn't write any delta x or delta y down on this problem. Therefore, we can eliminate equations 2 and 3. We can use the base equation for acceleration, which can be written in multiple forms. Basically, you can solve it like this. Acceleration is equal to Vf minus Vi over t, or the other equation that's on your sheet would be this rearranged, which is final velocity is equal to acceleration multiplied by time plus initial velocity. And so really you can plug it in either way. It's not going to make a difference. You'll end up solving for it. I'm going to go ahead and plug into the second equation I wrote down here. Final velocity was 30 meters per second, equal to an acceleration of 5 meters per second squared multiplied by t plus the initial velocity of 20 meters per second. So what we need to do here is we need to first get rid of this plus sign. We're going to subtract 20 meters per second off of each side. And when we do the final velocity minus the initial velocity, which is what we're doing right here, really that's the change in velocity, right? And so that should be positive 10 meters per second. That makes sense. So we've got 10 meters per second is equal to 5 meters per second squared multiplied by t. So we do need to divide now by 5 meters per second squared on each side. And we can see here that the time it will take Eddie to pass this truck is going to be 2 seconds. Okay. And that should hopefully make sense. You probably could have figured this one out without even going through the work here, but obviously we're going to practice. But if something is accelerating at 5 meters per second squared and it increases its velocity by 10 meters per second, it would take it 2 seconds to do that. 20 to 25 during the first second, and then 25 to 30 in the second second. Moving on, number 4 here, and our final problem for today. Reverend Northwick climbs to the church belfry one morning to determine the height of the church. From an outside balcony, he drops a book and observes that it takes 2 seconds to strike the ground below, and it says how high is the balcony of the church. So basically, let's just draw a quick book right here, right? That's supposed to be a book. Those are the pages. This is the bottom of the book. This is getting worse as I draw it. So we're going to ignore that. That's a book. And it is going to be dropped down, right? And so we know that the time it takes to fall is 2 seconds. We're obviously trying to solve here for delta y, right? So delta y is our question mark. And then in this problem, there are things that we actually know that have not been explicitly stated in the question prompt. We know that this object is going to accelerate because the force of gravity is pulling it down. G, lowercase g, is the acceleration value that is caused by gravity. We use 10 meters per second squared in here always. And then the other thing that we know that has not been explicitly stated is that the book had an initial velocity of 0 meters per second. It was dropped from rest. So initial velocity, 0 meters per second. So let's pick an equation. Did this problem give us a number for or ask us to solve for change in position? The answer to that is yes. It's asking us to solve for the vertical change in position, or the height of the balcony here. Okay, the change in position of the book or the height of the balcony. It's the same thing. Okay. And so we move on to our second question. Does this problem give us a number for time or ask us to solve for time? Answer there is yes. Again, it gives us the time. So what we're going to need to do is use equation number 2, which is delta y is equal to VIT plus 1/2 GT squared. So delta y is what we're solving for, which makes this easy. The initial velocity is 0, and initial velocity of 0 multiplied by anything is 0. So 0 plus, all of this needs to be multiplied together, 1/2 multiplied by 10 meters per second squared. And then multiply that by the time, 2 seconds squared. And that squared is only applying to the 2 seconds, not anything else. So delta y, if we simplify this, is going to be equal to 5 meter per second squared multiplied by 4 seconds squared. You can see here when you do this that the seconds squared are going to cancel, and you're going to be left with meters, which should be, which is the correct unit of measurement here. So we get 5 times 4 is 20 meters. All right, that is going to conclude problems 3 and 4 on your acceleration math practice. Thanks for sticking with me, and I hope you learned something.